All right, I'm going to make a tutorial to show how to take a bunch of elevation measurements and turn it into a bathymetric map for this lake right here, and how to calculate the water volume at different water elevations. So the first thing I'm going to do is import my elevation measurements. So those are going to be in here in point. I'm going to run that. And here they are. I'm going to drag them into my map. And as I zoom in, you can see there are a bunch of points crisscrossing throughout the lake. And if I open the attribute table, the only column I'm really interested in is elevation right here. So I'm just going to hide all the rest of these columns real quick. So I'm going to hide those fields and hide all of these fields. So for some reason, this elevation is negative. The elevation is the feet above sea level. So really it should be positive. So I'm going to calculate this field as elevation times -1 just to make it positive. And also, not only do I want the elevation, but I want the water depth when the lake is full. So I happen to know that down here on the south end of the lake, there's a spillway, and the elevation at the top of the spillway is 1052 or 1052 feet above sea level. So I'm going to go into fields view, and I'm going to create a field at the end here, and I'm going to call it water depth feet. And I'm going to make it a double numeric type. I'll keep the defaults for now. And I'm going to click save up here at the top. And I'm going to close that. So I have a new column, but it's empty. So I'm going to right click and go to calculate field. And I'm going to say 1052 minus the elevation. So I'll click OK. So at the lowest elevation under the lake, the water is 24.15 feet deep when the lake is full. And then at the other end, the highest elevation is 1054.13. So that's actually a negative water depth because that's higher than the spillway, but that's fine. So another thing we're going to need here in a moment is a polygon that has the area of the lake. So where do we get that? We get that from the USGS National Map Downloader. So you want to zoom into your area of interest, which in this case is Lake Rockwell, and you want to select hydrography right here. And I don't like the NHD plus. I just do the NHD regular data set right there. And I'll click search products, and that just searches in your extent right here. So there's only one data set that's here where I'm zoomed in on, and this is the one I want. So I'm going to download it. And I've actually already downloaded it, but normally I would download it and extract it. But I'll come back here and I'll go ahead and add, I'll go ahead and add that water body to my map. So I'll go into the hydrography data set and NHD water body. So that includes a bunch of lakes and other water bodies in this area. So I'll drag that into my map. But you can see it includes a lot of stuff that I'm not interested in. I really only want Lake Rockwell. So I'll right click that, go to properties, go to definition query, and I'll say I only want the lake where the name is equal to Lake Rockwell. So I'll apply that and click OK. And now I just have Lake Rockwell. So the next step here is to make something called a tin. So right now I just have a bunch of discrete points with elevations, but to calculate the volume, I really need a continuous surface. So what a tin is it's a triangulated irregular network. So for each point in here, it draws a line from that point to the neighboring points, and you can imagine it creates a series of triangles, and it uses the elevation reading to make sort of a 3D model kind of for the elevation. So I'm going to make the tin, and I'm going to clip the tin with the lake area that I just imported here. So let me go to geoprocessing and I'll go to create tin. I'll name the output tin. Let me just call it, I don't know, Rockwell bottom, I guess. For the coordinate system, I'll select whatever coordinate system the points are in. So we always use state plane Ohio North US feet. If you get an error about the coordinate system being undefined, you might need to go to geoprocessing and use the define projection tool and tell the program what coordinates the data is in. But it's already defined for this layer, so I'm not going to worry about it. So for the input features, I'm going to use my points with the elevation. For the height field, I'm going to use elevation. And I'm going to leave the other two default. And here I'm going to click add another feature class. And I'm going to use the water body. And it says use filtered records 1 because it only uses Lake Rockwell here. And the height field doesn't matter. I'm going to select none. And for type, I'm going to select hard clip because I'm just going to use it to clip the network that it makes. So I'm going to run that and uncheck the points and the lake area. And this looks pretty good. So these are the default colors for the elevation model. So the lower elevations are sort of a bluish gray kind of color. And the second deepest are the tan and green. And then as it gets more shallow, it turns kind of red, brownish to gray and then white. But this color scheme is used more for hills and mountain ranges and stuff. So I'm going to change the symbology a little bit. And I'm going to get rid of this edge. If you zoom in, you can see a blue edge around the outside. I'm going to uncheck that. And I'm going to change the color scheme. I like to do a custom one that goes from black to white and goes through blue. So I'll select one of the blues here and I'll click OK. And as I zoom out, this looks more like water. So we have the white over here on the edges that are more shallow. And then as it gets darker blue, it gets deeper. So the deepest part of the lake is actually right here. So right now it only has 9 classes. So it's only being, let me refresh. There we go. Okay. So now it's only being separated into 9 categories. So this up here is from 1051.21 to 1054-ish, and a little darker than that is 1048 to 1051-ish. But for a map like this, I really want as high resolution as possible. So I'm going to go all the way down to 32. You can probably do more than 32 somehow, but by default, 32 is the max. And this looks pretty good. So you can see it's darker down here where it's deeper, and then it gets lighter as it gets more shallow up here at the top. And you can even see the old river channel as it comes in before the lake was dammed up and turned into a reservoir. You can see the river came through here and it went that way. So that looks pretty good as a map, but how do we calculate the volumes? Well, to do that, we use a tool called surface volume. So I'll go to geoprocessing and go to surface volume. So the way this works is you define a reference plane basically. So I'm going to put in a feet elevation, which in this case is 1052 at the top of that spillway, and I'll select either above or below. So if it's above, it'll calculate the volume above that measurement, or if I select below, it'll calculate the volume below. So below is what I want. So I want to make basically a horizontal plane, at 1052 and then calculate all the volume below it. So for the input surface, I'll do Rockwell bottom, and it wants a text file to write the data to. So I'll just say elevation volumes. And again, I'll do below the plane, and for the plane height, I'll start with 1052, and I'll just do every foot down. So I'll go 1052, 1051, 1050, 1049, all the way down to the lowest elevation, which is 1027, which should be zero volume, should be 0 cubic feet. This Z factor, I'm going to leave at 1. This is like a multiplier to convert your depth. So if your depth reading and your coordinate system are in different units, you might need to use a conversion factor here. Like if your coordinate system was in feet, but your depths were in meters, you might have to put in a multiplier here. But all of this is in feet, so I don't have to worry about that. So I'm going to run that. And as you can see, it calculates the volume here in this text file. So I'm going to open that just to show you what it looks like. So the height is 1,052 feet, and the volume over here is in cubic feet, remember, and it's right there. I'm eventually going to want to convert that to gallons, but what I'm going to do is change this to 1051 and run it again, and you can see it just adds it to that same text file. So I'm going to go through and do 1050, 1049. So I'm going to pause the video and I'll be back when I'm done with that. All right, so I entered all of the elevations from 1052 down to 1027, and I just copied the text from that text file and pasted it into Excel and separated it out into different columns, and then I converted the cubic feet to gallons and then to billion gallons. So sometimes I like to make a little scatter plot of this like that, and I'll change the minimum here to 0. So this is the relationship between the feet of water elevation and the billion gallons that are in the reservoir. But I'll show you how to make this in this scatter plot in ArcGIS Pro. So I'm going to import that table that I just made the same way that I imported everything else, except instead of import feature class, I'll say import table. And I'll go here and I'll sort by date modified. I'll click refresh up here and you can see this table in here. I'll select sheet 1 and I'll click run. And I'll go back to my catalog pane and I'll drag that in here. So if I open this, you can see it's the same data that you just saw in Excel. So if I go to right click and create chart, I can create a scatter plot. And on the right here, I can define the x-axis as elevation and the y-axis as, let's say, billion gallons. And it makes a trend line, but by default, it makes it linear. I like to use polynomial, and you can mess around with these settings, but that's how I like it. There's a legend here that has the r² value. I don't like that, so I'm going to click the legend button right here to hide it. And that is pretty good. You can go to general and change the title here. So I like to say Rockwell elevation versus gallons, I guess. And I'm going to save that. That's pretty good. So I'm going to close that and I'll close that. So if you want to insert that, you can make a layout and select map frame, make a map frame right here. And you can go to insert chart frame and click that and then just draw a little square. And there you go. And then you can just kind of format it however you want. And you can add a legend if you want, but because we have so many classes, we have 32 different classes. Let me show you this. It's going to be really complicated. This is really convoluted for a legend. Nobody's going to want to look through this legend and match all these colors to the map. Um, there are a few options you have to simplify it, but I'm not going to go through all that stuff. I just wanted to make the map for now and calculate the volume. So that's basically all there is to it.